Code doesn't decay, but the context around it absolutely does. You write a system, ship it, and move on. Months or years later, the original developers leave, the constraints are forgotten, and the reasoning behind the code slowly rots away. This leaves future engineers staring at Chesterton's fence. They encounter a bizarre, seemingly irrational roadblock in the middle of a critical pathway, but have no record of why it was put there. Because no one knows what threat that fence was built to stop, the team is paralyzed. If you try to pull it out or route around it, you risk triggering the exact catastrophic failure the original engineers were trying to prevent. Without documented context, teams fall into a toxic loop. They waste months redebating old decisions, or worse, they accidentally reintroduce the very flaws the system was designed to avoid. Technical leaders cannot rely on mere authority to govern these systems. You need a form of continuous leadership that remains visible long after the initial architect has left the project. This requires adopting the persona of a wartime general of engineering. You cut through technical ambiguity by applying a rigorous battlefield discipline to every design choice. That discipline demands a militant focus on the why. You must capture the exact reasoning and the specific battlefield conditions present the moment a major architectural choice is made. Saving a system from the fog of war requires treating these decisions as immutable strategic orders. They are the defensive line that keeps the architecture from degrading into chaos. Before any command is issued, the architect gathers tactical intelligence. You must know the true terrain of the system before committing to a strategy. The essential framework for this intelligence is the architecture trade-off analysis method, specifically ATAM-Light. ATAM-Light identifies sensitivity points, decisions that profoundly impact a single quality attribute, like maximizing system scalability. But every choice creates a trade-off point. Improving performance violently pulls against security or reliability. One gain always comes at the cost of another. ATAM-Light forces the team to confront these compromises early. It exposes true design costs before the first stone of the foundation is laid. Once trade-offs are weighed, the final command must be formalized into an architecture decision record, or ADR. To make these effective, we use the lightweight NIGARD format. You start with context, capturing specific battlefield conditions and technical limits. Next is the decision section. This is the core of the record, requiring an absolute affirmative voice. A leader doesn't write, "I think we should." That's an opinion. You write, "We will." That's an executable order. Finally, the consequences section ruthlessly records the aftermath, listing the positive benefits and the negative trade-offs accepted. This format transforms a vague engineering conversation into a defensible, strategic command that future teams can rely on. Authoring the command is only half the battle. A decision record is useless if buried in an unread wiki or a lost email thread. First, proximity. ADRs must live alongside the code. Second, immutability. An ADR is an append-only log, a frozen snapshot never retroactively edited. Finally, superseding. If conditions change, draft a new ADR that links to and replaces the old one. These rules guarantee a permanent historical trail. They preserve the strategic thinking of the organization and eliminate the fog of war for everyone who maintains the system later. In its truest sense, an enterprise software architecture represents the physical accumulation of hundreds of these past decisions. By combining ATAM-Light for intelligence, the NIGARD format for command, and strict version control for governance, you build a system that can actually learn. This process creates an unshakable engineering memory. You are authoring an immutable legacy that survives personnel turnover, executive audits, and the test of time.